बच्चों अब हम फिजिक्स के चैप्टर 2 यूनिट्स एंड मेजरमेंट के ऑब्जेक्टिव्स और समरी देखेंगे. In after reading this chapter, you will know about the international system of units, measurement of length, measurement of mass, measurement of time, accuracy, precision of instruments and errors in the measurement. You will be learning about the significant figures, dimensions of physical quantities, dimensional formula and dimensional equations, dimensional analysis and its application. After this, summaries there, exercises and some additional exercises. This table is also very important table. In this, some base quantities are given: length, mass, time, electric current, thermodynamic temperature, amount of substance and luminous intensity. Then their SI units are given: length की meter, mass kilogram, time second, electric current ampere, thermodynamic temperature Kelvin, amount of substance mole, luminous intensity candela CD. Now I'll read summary for you. Summary: Physics is a quantitative science based on measurement of physical quantities. Certain physical quantities have been chosen as fundamental or base quantities such as length, mass, time, electric current, thermodynamic temperature, amount of substance and luminous intensity. Each base quantity is defined in terms of certain basic arbitrarily chosen but properly standardized reference standard called unit such as meter, kilogram, second, ampere, Kelvin, mole and candela. The units for the fundamental or base quantities are called fundamental or base units. Other physical quantities derived from the base quantities can be expressed as a combination of the base units and are called derived units. A complete set of units, both fundamental and derived, is called a system of units. The international system of units SI, based on 7 base units, is at present internationally accepted unit system and is widely used throughout the world. The SI units are used in all physical measurements for both the base quantities and the derived quantities obtained from them. Certain derived units are expressed by means of SI units with special names such as joule, Newton, watt, etc. The SI units have well defined and internationally accepted unit symbols such as M for meter, kg for kilogram, S for second, A for ampere, N for Newton, etc. Physical measurements are usually expressed for small and large quantities in scientific notation with powers of 10. Scientific notation and the prefixes are used to simplify measurement notation and numerical computation, giving indication to the precision of the numbers. Certain general rules and guidelines must be followed for using notations for physical quantities and standard symbols for SI units. Some other units and SI prefixes for the expressing properly the physical quantities and measurements. In computing any physical quantity, the units for derived quantities involved in the relationships are treated as though they were algebraic quantities till the desired units are obtained. Direct and indirect methods can be used for the measurement of physical quantities. In measured quantities, while expressing the result, the accuracy and precision of measuring instruments along with errors in measurement should be taken into account. In measured and computed quantities, proper significant figures only should be retained. Rules for determining the number of significant figures, carrying out arithmetic operations with them, and rounding off the uncertain digits must be followed. The dimensions of base quantities and combination of these dimensions describe the Nature of physical quantities. Dimensional analysis can be used to check the dimensional consistency of equations, deducing relations among the physical quantities, etc. A dimensionally consistent equation need not be actually an exact equation, but a dimensionally wrong or inconsistent equation must be wrong.